Welcome back to another problem solving tutorial, and in this tutorial I'm going to be showing you guys how to solve Leetcode question 581, the shortest unsorted continuous subarray. So a long name, but basically all it's going to do is it gives you an array and you need to find the length of the subarray within it, which if you sort that, this entire array is going to be into ascending order. Okay, so it's fairly simple to do once you understand the trick, and I'm going to be explaining how we can get to that in this video. So yeah, let's just take this first one as an example. Okay, so let's say we have this as an example, right? So straight from this you can see we aren't going to have, it's not in ascending order, is it? Because we go 2, 6 and then 4. 4 is less than 6, so obviously something's wrong there. And the question wants you to find this range, so we can just do it in our heads, but it's probably going to be 6 to 9. It wants us to find this range, which if we sort it is going to be in ascending order. So how could we do this? Well, one thing you might be noticing is you might just want to find the first item which is not in ascending order. So in this case it's pretty easy to spot because it's 6, because it goes straight to 4, so 6. And if we come from the back, we go this side, straight away we can see 10 isn't valid. So this seems to work here, right? We just have to, it's 10 is the pointer, but 9 is actually the one which is in the wrong order. So this method seems to work, right? All we're doing is we're just going from the, for the first one we go from the left and see which one is in the wrong order, and the second one we go from the right and see what's is in the wrong order. And you know, you would think that works, but there's certain cases where that won't work. So for example, let me try and think of a case. Let's just say this number was 16, okay? Now suddenly, even if we go from the right and we find that 9 is the first item which is in the wrong place, we might take this range, but you'll see if we sort this 16 is going to go into this spot, and it's still not going to be in ascended order because 16 is still less than 15, so it should really come over here. But yeah, so what you can see from there is we're not looking for the first item, but we're actually looking for the, if we're looking for the left bound, we're looking for the leftmost item for which there is still a item greater than it. So in our case, we start from the left because we're looking for the leftmost, so we're going to have to check all of these before we get there. But let's start from the right. 15 is first element, so we don't need to look at it. But 9, we're basically looking for if the element is out of place. So we first consider left bound and then the right bound. So 9, you'll see this is actually in the correct place technically because it has only items bigger than it onto the left. 16, now this is where we find our first error, so 16 has a 9 to the right of it, so clearly this is in the wrong place and we need to swap this, but we carry on and we need to check all of these until we find the one which is the most to the left. So 8, this is in the correct place because every item after it is above it, same with 4, but 6, there are items to the right of it which are smaller than it, so we know 6 is in the wrong place. And for 2, we know this must be in the right place because every item is bigger than it. So again, we've managed to get 6 here. And for the right bound, we're going to do the same thing, except now we're looking for the rightmost item for which there are items larger than it on the left side. So start at 6 actually. So 6 coming from the left now. This is in the correct place because behind it there is only 2 which is smaller than it. But 4, you can see immediately that is wrong because the 6 is behind it and 6 clearly is bigger than 4, so the 4 is in the wrong place. 8, all the items behind it are smaller. 16, same thing, all the items behind are smaller. 9, again, here is an error because 16 is bigger than 9, so obviously 9 is in the wrong place as it needs to be adjusted somehow to get this 16 in front of it. So we know 9 is wrong, and again 15, here we can see this is also wrong because there's an item or number behind it which is greater than 16. So we know 15 is also in the wrong place. So from there, we've checked all the items, and instead of just finding the first and first from the left item, which are in the wrong place. We've looked at the leftmost and rightmost, and this ensures that we've got the correct range. So leftmost and rightmost elements which are in the wrong place. Hopefully you guys understand what I mean by wrong place. An item's in the wrong place if it has an item before it which is larger than it, or after it which is smaller than it. So for example 8, or let's pick 6. So 6 has an item 4 after it, so this is in the wrong place. 8 has no, let's take 9. 9 has 16 before it, which is greater than it, so it's also in the wrong place. So yeah, it's pretty simple. We just need to keep track of, we just need to do 2 loops for left and right bounds. Okay, so let's create 2 variables now. First I'll start with the left bound, so left bound, and remember this is the leftmost item which is in the wrong place, so we need to start at this item over here on the very right. So let me just think how we're going to do this. We need to keep track of the greatest item as we come along. So let's just create a variable, let greatest element so far, actually no, we're looking for the smallest element so far, because the leftmost, it's in the wrong place if there's an item after it which is smaller. So smallest element so far, we can just set this to the last item in nums, assuming nums is, yeah, the length is greater than 1. Okay, now we can start this at nums.length minus 2. Okay, and while left bound is greater than or equal to 0, so this can go all the way down to the first item if it's in the wrong place. We're just going to check if nums left bound is greater than smallest element so far. So in this case, if we're at a random number and it's greater than the smallest number so far, remember this is coming from the right, then that must mean that there's a number to the right which is smaller than it. Sorry. Yeah, there's a number to the right which is smaller than it, which is definitely not what we'd expect. So that means current left bound is a number in the wrong place, and therefore we know the we can update this. Oh no, I'm being silly. We can just update this fairly easily. All we have to do is, let's just initialize this as the rightmost element, and then we can just use the for loop. So for let I equals left bound, I is greater than or equal to 0, I is less than or equal to 1, const current num is equal to nums I. If smallest element so far is smaller than current num is in the wrong place, so therefore we can update left bound to be equal to I. And if this isn't true, then this means current num is smaller than this, so let's update our smallest element so far equals current num, like so. Okay, there we go. So we should have created the left bound. This is how we got left bound. Now the right bound is pretty similar, except we're looking for the largest element so far. So because we can initialize this to be the first element, and yeah, okay, so initialize this as the first element, and we'll also set the right bound to be 0 for let I equals right bound, doesn't really matter, not equal to nums.length, and we're just going to be looping through from the left all the way to the right, trying to find the rightmost element which is in the wrong place. So pretty similar to above, current num equals nums I. If largest element so far is greater than current num, remember this element is behind it, so if there's a number behind current num which is bigger than it, then current number is in the wrong place, so we can update the right bound to be equal to I. Otherwise, this implies that current number is equal to or greater than the largest element, so therefore we can just set the largest element to the current num, like so. Nice and easy. Okay, so from here, let's just console.log our left bound and right bound, and we'll probably just have to do some finishing up, but hopefully you can see what we mean. So find unsorted subarray, and I'll just use this example. Okay, so left bound and right bound are 1, 6, so 1 and 2, 3, 4, 5, 6. Okay, there we go. So we've got our two bounds. Now all we have to do is return the length between them. So how are we going to do that? Well, we might just, let's just count 1, 2, 3, 4, 5, 6. So we can just return right bound minus left bound plus 1. And this should give us 6, which is, oh yeah, this is a different example. You'll see I changed it a little bit if we put this back. Yeah, we get 5. And I'm just going to test it on an edge case just to make sure. Okay, so there seems to be a bit of an issue. Let's see what's going on over here. Left bound, and see, this is the issue. You really have to also think about the edge cases. So both left and right bound are 0, 0. So what does that show? Of course, we need to consider the case where the items in the array are fully sorted. So for example, if we have this, we've somehow managed to get minus 2, and that's because the left bound is actually greater than the right bound. Okay, so how am I going to solve this issue? Okay, so one thing you'll notice is for the left bound, over here, we're basically starting from the right and we're just going along until we find an element which has an item to the right which is smaller. So if this never happens, then that means that the array is going to be in sorted order, and therefore if we initialize this as nums.length, then if the array is in sorted order, if array is in ascending order, then left bound will never change. So using that knowledge, we can check if left bound is equal to this, and if that's true, we'll just return 0. So if left bound equals nums.length, we're going to return 0 because there is no subarray, there's no need. Otherwise, we'll simply just return the original. Okay, and there we go. So again, I'll just check the edge case just to make sure we get 0, and then let me check this case. Okay, that's looking good. So that should be it. Hopefully you guys could understand my explanation, and let's just see if we can manage to get through, and we do. Okay, so yeah, this is actually a pretty good solution. I've thought about it a lot, as you can see, but managed to beat 92% of people, and we get 84% memory, so this is really good. Thanks for watching, and I'll see you guys in a future tutorial. Bye.